Got another UPS to look at here. This is that troublesome Tripp-lite that I replaced a battery on a couple of years ago. Well, it's acting up again, and I thought for sure it was going to be the battery, but it's not the battery. The battery is fine. This time it just went into a fault condition and turned itself off. So let's see why this broke and see if we can fix it. I have here a Tripp-lite UPS. And it's showing it has a fault. This is showing the incoming voltage. This shut down when it was being used. It just shut off. It started to beep, and then the power went off. And I noticed it has the fault indicator. Now it's not indicating that the battery is weak. I'll shut off the incoming power and see if it goes into inverter mode or whether it shuts down. So now it's running on battery. And that buzzing is normal when it's running on battery. Turn the power back on. Now it's gone back to power again. We'll see if that fault indicator reappears. Now, I don't know why this went into fault unless it detected an overvoltage. As you can see, my voltage is pretty stable here, 119 volts, but the meter on this thing is all over the map. I don't know whether that's what caused it to go into a fault. Let's just increase the voltage here and see whether it will trigger something. Unplug anything that might suffer from overvoltage as I crank the voltage up. Okay, now it's gone on to battery. You see, that's what it's supposed to do. At 138 volts, this thing went on to battery. I'll bring the power back down to 120 and it should switch back. And now it's gone back to power, like this thing is operating as normal. Let's turn the voltage down and just see. Oh, it's gone back onto battery now. So let's see where it switches to battery as I start to drop the voltage. Okay, so now it's gone on to AVR, automatic voltage regulation, which means that this should be boosting the voltage up. The inverter in here should be operating, but it should be operating just using the mains voltage as opposed to battery. If I convert it back up to 108 volts, and we'll plug a meter into the output here so we can measure the output so you can see that that's working. I'm just curious as to why that fault indicator came on in the first place, and just allowing it to go into battery mode seems to have reset it. That's weird. Let's watch what happens as I dial down the voltage. I have a 60 watt incandescent bulb here plugged into it as well, so we've got some load on here. As you can see, both of these meters are measuring 120.8. This one's fluctuating between 118 and 125, so obviously the display on this is not 100% accurate, but let's watch what happens as I drop the voltage. So the light will start to dim, and once the AVR kicks in, it should bring the voltage back up here. So we're down at 106. I think when it gets down to 100 volts is when it should kick in. We should get an indication here when it does that. There we go, and you just saw the light get brighter. And now we're back at 115 volts. As I continue to drop the voltage here on the input side, you can see that the voltage, now it's going to go to battery. and now it's gone to battery. It's actually switching back and forth, and it's telling me that it's on battery. And if the voltage drops off even more, it'll go straight to battery. So now I'm down at 95 volts. It's now strictly on battery. It looks like the battery probably is bad on this because that went down awful quick. That might be why it was faulting. So maybe we'll take this opportunity to change out the battery on this thing. You can tell from how that light is fluctuating that this is not real clean power. I mean, it doesn't seem to be fluctuating that much. It seems to be on the meter here showing it's going between, 114 and 118. So it's not exceeding and it's not dropping really, really low. Now if I cut the power off completely, now there's no power coming in whatsoever, and we're still getting power from the battery here. But this may be the battery is getting weak. Either that or the inverter has a problem. If I turn the power back on, if I bring the voltage up, if I get above 100 volts, it should go into AVR mode first. It might not turn back on until it gets to 120. Okay, there, it's gone back. The inverter is shut off at 105 volts. Now if I go too high, it should go on to battery. And there we go. Now it's gone back on to battery. I did that at 138 volts. If I drop it back to 132, will it kick back? Probably won't. It will probably hold it until I get down to about 125 or 120 before it switches back. So I'll bring this back down to, I'll take it down to 125. There we go, 125, close enough. Will it switch back or does it have to go to 120? Looks like I have to bring this down to under 120. And now it should switch. It should switch back. There we go. It's gone back to power, to mains power. If I drop it down to 105, it should go into AVR mode. And then we should see this jump back up. There. So now it's in auto voltage regulation. The 102 volts that is being fed is being brought up to 115, but we're not using the battery in this. This is just using the internal voltage regulators to step up the power. And it kicked back out there. Seems to be that sweet spot. Right around 100 volts that it's going to kick in. And it probably shuts off at 105. There we go, 105. Bring it down to 100 volts and it will kick in. Bring it down to, I think it's 95, and the battery should start. So I'll just drop it a bit more and we'll watch that again. There. But that was weird how this, you guys saw the fault. I'm going to power it down. And we'll power it back up and see if this thing shows that fault again. I think I guess got to hold the button. There we go. Now it's off. And if I press and hold, now it's working. That is a really bizarre problem. You guys saw it. And this was running. This actually shut down when it was running. That's what drew my attention to it, is that the equipment that was protected by it just shut off. So I think we'll change out the battery. The battery that I put in here was not a new one. It was a used battery that I put in before. And we'll grab another one because this battery is quite old. I'm sure it's probably at the end of its life or getting close to it. As you saw when I powered it down here and it went into battery mode. This voltage, as I say, is fluctuating a bit, as you can see. But this went down pretty quick. And that's something to remember when if you're working on these UPSs. Even when the input power is shut off, these things can still be putting out power. So make sure before you open one of these things up that you actually shut it down completely. Otherwise you could get yourself a nasty shock. Okay, power on. Set our output to 120. I haven't turned this on yet, so press and hold. And it's doing the fault again. Interesting. Notice that the meter on the right just went to 0. This is what it did when it failed. Do you notice that my voltage has gone to 0 on the input? I better check the fuse in my Variac. Yeah, I would say we have a fault. Okay, before we try this again, now I've got this plugged into my current limiter, which is up there, that light bulb that's mounted at the back of the bench. So that will limit the current. This is the current limiter plug here. That will limit the current to 1 amp. So here we are, 120 volts or so. And when I turn this thing on, I expect fully to see that that light bulb is going to light up bright as anything, because that'll indicate that there's a dead short. So let's turn this thing on. I'll just frame this up so you guys can see the light in the back corner there. And that light up there should turn on full brightness as soon as this thing tries to turn on, which will indicate that there's a dead short somewhere in here that we have to investigate. So power on. Well, it didn't blow the fuse this time because, but it also didn't turn on. So the last time when it popped that fuse, it drew enough power to pop the fuse, but it then shut down immediately. I saw nothing from that light. Nothing whatsoever. But it's not turning on. Now if I were to put a dead short across the line cord going into that light, you would see that light would light up full brightness. That's a 100-watt bulb would light right up, because how it's wired is the AC power, which is being fed through this plug. This one's powered up from my bench power supply. This one's going into the light bulb, and it's in series with the plug that this is plugged into. I now have my meter here plugged into the back side of the UPS. So this one's plugged into the battery protected output, which you can see is at 0 because it's off. This one's plugged into the unswitched. So now if I unplug this cord, you'll see that that voltage is going to drop to 0. Right? We have power making it through here. When I turn this thing on, you see this just drop momentarily. Right? And then it shut down immediately. But without that resistive load on the input, it blew the fuse. But we've got the fault indicator showing up on here, which is what happened before. So pull this thing apart and see if I can spot anything. You guys want to see what will happen if I short these together? The light will light up. If I can get them to short. Trust me, it'll light up if they short. That light will light up. If I were to put something between these two here, normally you would see major sparks, but in this case, you'll just see light. If I can get something to touch the wires, touch the pins when I'm connected. There, you see? That's what would happen if there was a dead short. That's why it's good to have a current limiter when you're testing the unknown, because it'll prevent things like sparks, arcing, and blowing fuses. Because you know, nobody wants to blow a fuse, they're expensive. That brings me to a story of a guy that I used to work with. Let's call him Old Pete. That wasn't his name, by the way. That was not his name. I'm just making that one up. We're going to call him Peter. But Peter had a habit of, even though we had the light bulb tester in the bench, had it made into a little box, and we had it there, and old Pete would never use it. He'd put a fuse in it and pop the fuse. He'd go get another fuse and he'd pop the fuse again, and in the course of servicing something, he might pop, you know, a half a dozen fuses, and before he figured out what the problem was. I used to shake my head saying, well, you just use the stupid, we've got the current limiter, why don't you use it? You know, save a bunch of fuses. Of course, then the boss saw these fuses that were getting blown up, and the boss got mad about that, and locked horns with old Pete a few times, and old Pete got the message and retired. I don't see anything burnt or arced or anything on the board. I'm curious as to why it did that. Well, we'll try it again. Try powering this thing up with it apart and see whether it does anything. So there's my main power. And it's working. It's in battery mode now. Okay. It's on battery. Well, something's wrong, because it's as soon as I turn it on, it starts up in battery mode. Now there are a couple fuses on this thing here. I don't think they're popped though, but we'll check. It's 40 amp fuses, so I don't think these things are going to pop. They got two 40 amp fuses here that are in parallel with each other, right there. I don't think those are going to pop. They're like automotive fuses. Those would be probably from the battery, I'm thinking. I'm positive that's what those are. Those are going to be fuses from the battery to protect in case of a short. Let's see here, where's the battery power? Because I'm positive that's what that's going to be. Is that going to be battery protection? 40 amp fuse, yeah, that would be bad. Definitely battery protection. Battery comes up. Battery lines are down here. 12 volts. Yeah, that's exactly what that is. Here's the 12 volt line, and this is the negative line, 12 volts. So that's what those fuses are for. That's just in case there's a short somewhere. 40 amps at 12 volts, because a dead short of battery and the battery could burst into flames, right? So that's the battery protection on here. But why it's acting the way it is beyond me. Let's just dig a little deeper on this thing. Here's something else to keep in mind. Even when the AC power is disconnected, right, you can still turn these things on in battery mode by just pressing and holding the power button. Now, when this thing was together and it had its fault, it would not even turn on in battery mode. So it's got to be something was shorted. Either a wire was pinched or something. I'm just going to check for that. Maybe a wire got pinched. Anyway, before I work on this inverter, I'm going to disconnect one terminal of the battery because I don't I don't need this thing turning on while I'm working on it, if you know what I mean. Don't need to worry about getting jolted from our inverter. So safety first, disconnect the one lead from the battery before doing any work on any of these boards. And I'm just going to look and inspect and see if I can see any connections that might look like they're maybe loose, or like some of these ones up here. Gonna do a close inspection. I don't know about you, but that looks like a short right there. Just gonna get in with a pick, so clear that out. I'm going to just resolder some of these some of these connections here on this IC. Some of them don't look great. So I'm just going to heat up my iron with a fine point and go over a few more of these things. Then we'll do another test and see whether it's going to operate or not. See what the heck is wrong with this thing. Why it's faulting like it is. It's weird. And in case you ever wonder why we have protection on batteries, well, this battery, watch what happens if I short this. It'll just make this, it'll make this solder explode. Just like that. It just melted it instantly. A lot of current in these lead acid batteries. We definitely don't want that now, do we? I'm going to put some flux in there. This is, solder's not sticking very well to this IC. Let's put some flux on it. I can't see if there's any bridges in here. I'm going to clean this stuff off. My flux has gone kind of, I had a bit of a leak on the bottle. It's gone kind of really thick. So I'm going to have to clean all that out and get rid of the bridges, because I'm sure there are some in here that I cannot see. Like this one here. I can see this one, but I can't see some of the other ones. So I'm going to get in there with the toothbrush and clean that mess out. One thing I have noticed on this is this plug has got that circuit glue all around it. I'm curious as to whether it's down into the plug and is shorting the pins. Probably not, but it's gonna, no, it didn't. It wasn't into the pins, so that's okay. That stuff gives trouble, as we've seen before many times. I've just gone over the board and looked at it, and other than resoldering the ICs here, it doesn't look to be that there's really anything that's obvious on the board that's causing a problem. We'll try powering this thing up again and see what it does. So once again, I'll reconnect the battery. I should be able to power it up in battery mode at this point. If I hold the power button. Oh! Well, look at the difference we've made here. Remember it was flickering like crazy before? It's not flickering anymore. Let's just try powering it up on mains. See if it's going to work. So mains power on. Interesting, it's back on battery. Now I wonder if it's not going on mains because I'm going through a light bulb. Maybe that's why it's not going into mains, because seeing the resistance from the 100-watt bulb that's in series with it. I'm beginning to think that's why. You see, it's trying to kick into normal power. Of course, that's going to put the light bulb in series with... If I turn out the light here, I wonder what happens. Whether it'll kick in. Ah! It's because of the load, because I'm going through that current limiter, of course, which will drop the voltage. That's why. See, if I turn on the light, it immediately goes into battery backup, because I'm, of course, dropping my voltage going through a light in series, all to prevent my fuse from getting damaged due to a short, which it did the first time I powered this thing up. So maybe what I should do is reassemble this unit, and we'll power it straight up from mains without going through my isolation transformer or anything, and see whether it still acts up. Let's see if I can get this thing to go together without anything complaining. I'll try powering this thing up again. And okay, it should be on now, I think. That's off. That should be on. We'll move this to non non-regulated or non-current controlled power. Okay, here it is once again. It's plugged in. Nothing's blowing up. We'll turn on the light. Light is working. Input voltage, output voltage. We're on the variac. If I take the voltages down, it should kick into regulation mode here momentarily. Okay, now it's on AVR mode. Boosting our voltage back up. If I can continue to drop it, it should go into, or if I turn the power right off, we'll drop it some more. And now it's gone into battery mode. And if I bring the power back up to 120, it goes back to regular. So it's working. And if I increase the voltage to I think it's 140, there, it's gone back to battery. So that is now working again. Now it'll kick back into, there we go. Now it's gone back into normal mode and I don't have a fault. So I'm going to let this charge this battery up and keep my fingers crossed that this is now functional. Thanks for watching, and we'll catch you in the next one real soon.